Hello and welcome back. Alright, so I have a little bit of news for the small subscribers that have subscribed to me and maybe watch me. I have changed the name from TM Designs to Dev Theory, primarily because of what I want to do with this channel and because the name TM Designs is literally buried in search results. So I've decided to change the name so that it's easier to find. But there's something I want to do with this channel, and I'm a big time fan of game theory and film theory, and something I think they can't cover, but I can cover because when I first started developing, I started developing as a game developer. I actually got pretty far. I produced my first game. So I still want to follow that route eventually because I do want to create games, but it's more profitable in the first few steps to become a developer that works with web technology. But I do want to continue making games, and one thing that I want to do with this channel, if I get enough people looking at my views, if I get enough likes, is I want to take the glitches that I see people show on their own channels and show how to do on their own channels. And I want to take it and I want to look at it from a developer aspect because, for one thing, I find it absolutely fascinating why these things happen and why it's so important to be diligent in your code. For instance, the Nintendo 64 glitches where you can just clip through walls is usually due to the fact that the wall is not thick enough and the character texture is not how to say this. The character texture is thicker than the wall. So the second that a pixel gets outside of the boundaries, the second the code starts to mess up. And because the rest of the code technically works, it's just the code on that wall that's breaking, you're able to clip through the wall. Now, there are also different methods for that to happen, such as the developers didn't think that anybody would try to go through that corner. And that's another point that's great to cover because that shows where you think something won't happen, there is likely something to happen there. Because you noticed that something was there, that kind of points out that there will be something there. So I kind of want to take the game glitches eventually when I have the time to lay out like scripts and whatnot, and where I'm not just going off of what I'm saying. I want to take the time and analyze these different glitches. But for right now, we're in the Android tutorial, and there are a few things that I want to show you today. And that would be the way to find out your errors and to let the consumer know, or the user know, or the end user know, there's multiple names, that there's something happening within your code. And the way you find out that something is happening in your code, other than this debug box down here whenever your application actually runs, and I'll go ahead and start the application because it takes quite a while. This box is useful for whenever you find something out, something is wrong with the system. But whenever I first developed a JSON application or a SQL application, I would use something to point out which steps managed to make it through. For instance, whenever I was dealing with the JSON, first you have to pass the information down, it's passed up into the method, and then it's passed through the class, and then it's passed down again, and then through the method again, and then finally used. So that's a lot of different steps where something could go wrong. And that's why finding out if a certain area messed up or if it didn't actually reach a certain area. That's why that's important, because sometimes it's a syntactual error, and it's not a compile error, but rather you type something wrong. That's when that type of logging comes in useful. The reason why it came in useful for me was because when I was first developing with JSON applications, when the data was finally passed through the second time, it wasn't actually reaching my statement to use it. So what would happen is it would go through the statement, realize that it didn't match the statement, and it wouldn't log the message. And that's how I quickly found out where my application was going wrong, because technically all the code compiled correctly. It's just my statement wasn't correct. So that's a very important reason why you should use logging in finding out where things go wrong. Okay, so it looks like my emulator is up. And another thing on the opposite end of that, the end user, is what happens if a network permission goes out, right? What if they have no internet, but they don't know that your application isn't activating because there is no stream of data? Believe it or not, considering that my mother works for a person who saw my code pen, which I took a few pictures from her website and put them in some carousels, that's all I did. And my mother works for a person who thought I was stealing photos from a website, and she was nervous that her primary developer would find out and get angry that I was messing with the website, even though it's on a code pen. And yeah, that literally, logically, to us as developers, makes no sense. But because a person of technology doesn't know how the technology works, it makes them very nervous. So a person like that would need to know, hey, your internet is not working, or hey, you are in airplane mode. So that's very important on the end user side. So that's why those are just a few examples why logging and something called toast is very important. Alright, so I decided to cut out a little bit of the video because the emulator takes quite a bit of resources. And just so you know, in the future, whenever you're doing anything, you don't actually have to close the emulator. And this is a very important fact that I learned way too late in developing Android, because I would say that I probably wasted at least 3 hours reopening the emulator every single time. And you honestly don't need to reopen the emulator. Some of you may have realized this, but others, like myself, would say, what? You could do that? Yeah, sometimes we make mistakes, and that sort of thing happens. Okay, so the first thing we gotta do is we gotta have a toast, right? We have a toast. Well, the problem with this is that we have a click listener. So let's open this up and bring it into the emulator. And this should not take very long because the application is quite small. And there we go. And as you can see, the debugger is working and it's letting us know. So whenever I click this, it moves on to the next page. Alright, so what I want to do is when this is clicked and it actually sends it to the next page, I want to bring up a toast and let the program know that something happened. So the first thing I'm going to do is actually not edit the main profile, but go over here. Now on create happens whenever your specific layout is created, okay? So when this is on created, all this code underneath it runs. So the first thing that we want to do is we want to create a toast message, right? And we want to say toast, and we're going to create a new toast. And as you can see, it's wonderfully launched everything for me. However, this is a bit convoluted. Okay? This is the short way of doing things, sure. But this is a bit convoluted. You can't reuse this. You cannot make this method multiple times, right? You can't reuse this code. And that's okay. We'll explain what it's doing in this one and then move on to what you can do with maybe reusing it in several different methods. But the first part that I want you to notice is that this became a ... And that's because in order to use it, you have to import the widget toast. Now, the reason why I want to point this out to you is because the Android device is the pinnacle of modular, which is a computer science topic. Essentially, it modulates all of its code so that you don't load this giant database of code onto your application, because the database takes up space, and your application has to first go through all of that code in order to get to the point of creating your application in the first place. So what the Android developers did very intelligently is they modulated it. They created modules that you could import and then use. So with Android, you will be importing a lot of modules. However, the very basic ones that you'll be importing are the OS bundle and the support v7 app compatibility. This, of course, is the operating system bundle, which is everything that is required to actually make the application work. This is to provide compatibility to all other devices of this version and forward. Now, in the widgets class, we've already seen how to identify by ID. This is working in very much the same way. Essentially, we're contacting Android, accessing the widget folder, and accessing the toast code. So, that's what's happening here, and it's very important that you have these set up whenever you try to test your code, because you can actually have different versions of imports. Because while you may be importing toast, what if we just want to import make text? What if that's the only thing we want to import? And we might want to do that because, as you can see, we're extending toast to use the method make test. So in those cases, you might want to have multiple different versions. And if you don't have multiple versions and you just have the parent class, you'll have a lot of concatenations in order to access those different methods. So let's go ahead and explain what's happening in this code. So as with the intent, we first have to tell toast where this toast is going to be. And it's saying that the activity that it's currently in, which is called second activity, it's where it's being generated. And then the second message is the message. It's a string of words that you can use to determine what message you want to give. So we'll say this is second activity. And then the last one is how long the message actually shows up on the screen. Now, make text makes the text and takes in these parameters. In order to create a new toast, all you have to do is go toast, let's say fada blah, and then new toast. we just pass in second activity dot this, and there you go. So this is just saying where we want it to be created, right? And then we can just target the show method. Now, obviously, this is a little bit redundant, and you can obviously just remake things over and over and over, which is why whenever the IntelliJ application actually uses the toast message, it just uses a single concatenated line instead of storing it. Now, what's the difference between reusing code and using new code? Well, for one, reusing code actually takes up less memory. Now, you may not think about this, but whenever you first use code, it takes up a specific part of the memory, right? Whenever you put up new code, it takes up new memory. So if you're going to have a lot of toasts inside this method, setting up an initial memory for the toast, just creating a new toast object instead of just using the method itself, takes up a defined portion of the memory. If you constantly make new texts and are creating more objects, then something called the garbage collector, the thing that comes through and collects all the memory, will have to create an overview for all of those new objects. So there is a benefit and a downside to this. Now, obviously, if you're only making one toast message, then the memory difference is actually beneficial to creating the new object using the single method. But if you're going to be reusing the toast to do multiple things, then obviously you want to have it up here, right? You want to have it as a class object so that you can reuse it over and over throughout your code instead of creating a new object every single time. Okay? Now, the show method actually shows it on the screen, and the toast has several methods, right? It has length long and length short. So let's go with fada blah, and then here we go. Set gravity. Now, by default, your application will put the toast in the middle of the screen. Okay? This is setting up where you want it on the screen as you set the gravity. Where is the gravity? So as you can see here, I've said I want it to show up at a gravity of 1 and set up the 1 and the 1 on the XY axis. Now, whenever you bring up the XY axis, it's actually starting at this corner right here. So in other words, it should show up right here. But because of the gravity, it's going to show up somewhere down here if it shows it up at all. And to determine whether it's going to show up at all, we actually have to find out this. As you can see, it says match parent and match parent, right? So if we bring this up and we activate the second activity, what should happen in my mind is that it may not show up at all. Here we go. So as you can see, this showed up right down here, right? But if I were to increase the gravity like this and change the application, as you can see, it didn't show up because the gravity is actually taking up more space than that's on the screen. And that's because the gravity sets the importance of the object. So if the object has a higher gravity, then it's going to take up more space on the screen. And the reason why I thought that the match parent would affect where the gravity was is because the match parent shows up all around this object. But I was a little bit wrong because the match parent also includes the Java, and so what that does is it actually puts it inside the screen. But because there's a default amount of space that is set up through the application, the 1 is the default of all objects. Is the default. Because if it's 0, then it doesn't show up. So if I were to make this 0, and then make this 0, as you can see, it showed up once again. And that's because I've offset it back to its original position. However, if I just remove this, then what should happen is that it should appear in that place anyway. That's the default place for it to happen. As you can see, it happened right there. You don't need to set the gravity if that's the place where you're going to have it in the first place. And most applications do not set the gravity. You only set the gravity in specific cases where the activity is happening within a certain box. Okay, so now that we've set up the toast and the make text, and there's actually a little bit more to the toast, but that's essentially what you need to know. The rest of it is special cases. So these will be cases where, say, you need it to go within an activity of an activity, or it's for special cases that don't happen very often, but they do happen. Okay, so that's how you make a toast. Now, how do you make a log? Ironically, you just put log. But there's a few options, right? And as you can see, it's already used util.log, and that's because it's part of the utilities library, and it's not part of your application by default. Now, there's a few methods, okay? There's quite a few message options, and that's because they're for different types of things. Okay, they handle different types of data, but most of them take something called a string tag and then a string message. Now, what's the string tag? A string tag is you letting yourself know where the hell it happened. Okay? That's what it is. And a string message is for whenever you're trying to actually provide yourself a message of what could have possibly gone wrong. This is entirely for you, and all the logs are generated and kept on the machine. So if something happens on the machine, it's possible that the application didn't get rid of the logs. But because Android tries to make sure that the application doesn't take up the entire memory, it also tries to clean out the logs every now and then. So whenever you create a log tag, you need to set it up for one of its many different tags. V is your view. So it's a log for the view. E is for error. I'm not sure what D is for. I actually haven't needed to use that. Most of the time, you'll just be using this first one. That's where you'll be using most of the time. And then E is for and just a syntactual error. As you can tell, this handles a throwable error, and this handles just an error in general. And then I'm pretty sure is for an integer. And an informational error, maybe. And is loggable is just testing whether an object can be logged or not. And that's for your more extreme cases. This is, again, the log method comes with a whole bunch of different options that you may or may not use. But view, the one with a V, is usually the one that you're going to be using most of the time. And as you can tell, they do have a little bit of humor here in WTF. And most of these are, you can use almost all of them for the exact same reason. The only difference is that they're for you. They're for you and how you find something. So we're going to say second activity, right? And then we're going to pass in reached message. And we're not going to throw anything. Okay? And then all we're going to do is we're going to run this application. We don't even need to look at the application because it doesn't show up on the application. As I said, this is just for you. As you can see, it showed up as a V and showed up as second activity and reached message. Okay? So in other words, this allows you to determine where it took place and whether something was done or not. And as I said before, I've used this to run through my steps in order to find out if something is working properly or not. And let's make something go wrong. Okay? Let's just remove that. Right? Now, it'll fail, and I want to show you something. As you can see, if it's a compile error, it'll show you what's wrong. Now, what this is saying is that error, no suitable method found for vString. Method log.v string is not applicable. So in other words, it's telling you that you're missing a string. Okay? And then if we run it again, it won't fail. Hey, give me my, give back. I want my thub. Okay. So that's the compile error. Let's go back, and I saw a red here. We don't want the small reds. We want a big red. I want to find one of the big ones. I mean, I can do it with a small one, but it's better if you do it with a big one. Okay, so let's just find a small one. What you'll see in your code is something like this, right? But it'll be much bigger. The reason why I wanted to go through the big one is because the big one is the one you'll see whenever you actually have a problem. You don't need to pay attention to things like this because it doesn't actually affect your code. And the reason why these types of applications have these errors is because of old, outdated code. And when you see the big message, you'll see a big error. And the top of that error and about the middle of that error is what you want to pay attention to. The reason why you want to pay attention to these is because the top of the error tells you where the error actually happened. And then the middle of the error usually is what happened within that activity or within that piece of code. I ran into this quite a few times whenever I was parsing my JSON incorrectly. And that was because I was learning out how Android was doing it. But those two places are where you will find out what's happening in your code. that's going wrong, right? So the log v message is for really testing your own code to make sure the logical syntax is working. In other words, it's for general cases where you can test your code where the Android system cannot detect it by default, right? But the application is very good at handling its own errors because the Android team knows exactly what you're looking for, so the error messages that occur are usually very, very well detailed. And then it'll have a stack trace, right? You'll get 2 errors or 1 error, usually 2 if you're doing something big, that tell you where it's at and what line it's at. But in between that, all the red that's in between that and below that is usually called a stack trace. And the reason why a stack trace is important is because when you're doing like really complicated stuff, like pulling in from two different locations, the stack trace will tell you where your code is going and what methods messed up. And once you understand how to use Android enough to where you're actually pulling from 2 different JSON locations, you'll understand how those methods are working, and then you'll be able to backtrack to where your error is. So, for example, whenever a JSON request fails, it doesn't just fail. It fails because this method couldn't convert this type of method, and then the method after that couldn't convert this type of method, and then, it's a domino effect. So once you understand Android pretty well, you'll be able to understand your stack trace back to the point where what you are doing is causing the domino effect. Alright, so that's it for this video. Go ahead and like, subscribe, or whatever. And I'll see you in the next one. Oh, and links in the bottom, of course.